a variation of parameters for a third order differential equation. So let's say we have, I don't know, y triple prime plus 9y double prime plus, I don't know, 9y prime plus 81y. And we can set that to, I don't know, cosine of t, I guess. Doesn't always have to be complex. We can use variation of parameters or method of undetermined coefficients. It doesn't really matter which one you use. Although undetermined coefficients is the preferable one because it's considerably more simple, but we'll use variation of parameters for this one. So we have y triple prime plus 9y double prime plus 9y prime plus 81y equals to cosine of t. So we'll solve for the characteristic solution. Now that we got r equals 0 plus or minus 3i and negative 9, we know that the multiplicity of each solution is just 1, so we don't need to multiply by any t's. So y1 of t, we'll just take positive 3i, we get e to the 0t cosine of 3t, or just cosine of 3t. We get y2 of t equaling e to the 0t sine of 3t. So again, that's just 1, and y3 of t is equal to e to the negative 9t. Okay, so we got that. Now, we can try to find the Wronskians first. So let's try to find the overall Wronskian of this first. So that's cosine of 3t, sine of 3t, and e to the negative 9t. Negative sine 3t. Oh, negative 3 sine of 3t, 3 cosine 3t, negative 9 e to the negative 9t power. Then we differentiate again, because we're finding a Wronskian for 3 dimensions now, or 3 solutions. So we have to differentiate one more time. Sorry for the sloppy handwriting. Then remember, we take the determinant. So we get something a bit complex. We get cosine of 3t times 243 e to the negative 9t cosine 3t plus, or no, that's still minus 81 e to the negative 9t power sine 3t minus sine of 3t negative 243 e to the negative 9t sine of 3t minus 81 e to the negative 9t cosine 3t plus e to the negative 9t of times 27 sine squared 3t plus 27 cosine squared of 3t. Okay, so we have a lot of stuff to unpack here. So let's first of all look for anything that cancels out with each other. That would be nice. So let's first of all simplify the negative sign. Okay, so kind of looks like not much cancels out here. We can factor, oh wait, this should be squared. So this would be 27 e to the negative 9t because of our trig identities. But overall, it's not looking too great, but we can try to figure this out. So cosine 3t, negative 81, and sine of 3t, these cancel out. So we have 243 e to the negative 9t times cosine squared 3t. And we have the same thing on the second term, so we have plus sine squared 3t. So this is equal to 243 e to the negative 9t because of our trig identities. So we have this plus that. So that's equal to 243 e to the negative 9t plus 27 e to the negative 9t. So that is equal to 270 e to the negative 9t. That's our overall Wronskian. Now, remember, our final solution is not that simple. We're not done here. We have, I'll write the solution in a different notation. We have I to the 1 of, well, in this case we have 3 solutions, so 3 goes on top of y to the I t times integral of, or ui of t. Remember, ui of t is equal to the integral of Wronskian I of t, g of t, dt over Wronskian. So let's see what we can do to all of this. So let's find u1 of t first of all. Let me give myself a little more room. So u1 of t is equal to first Wronskian, which is this one, negative 9 e to the negative 9t sine of 3t minus 3 e to the negative 9t cosine 3t times g of t, which is cosine of t, dt over that Wronskian, so that's 270 e to the negative 9t. So e to the negative t's cancel out. We have integral of 1 over 270 times negative 9 sine of 3t minus 3 cosine of 3t times cosine of t dt. And you know, I could use some trig identities, or I could use integration by parts to evaluate this, but I think this is as simple as I can get it without taking up too much of your time. So to generate our first solution, we would have to just multiply this by y of t, y1 of t. So we would get, or we would pull this, add cosine of 3t. And then that would be our first solution. Okay, now that we got the more arduous calculation out of the way, now we can just solve for the first Wronskian. Determinant of 0, 0, 1 sine 3t, 3 cosine 3t, and negative 9 sine 3t, e to the negative 9t, negative 9 e to the negative 9t, 81 e to the negative 9t. And it's considerably more simple because, well, the first row is completely taken out. So we would get 0 times blah blah blah, it doesn't really matter, minus sine of 3t of 0 plus 9e to the negative 9t plus e to the negative 9t of 0 minus 3 cosine 3t. So we have 9 e to the negative 9t sine of 3t. Remember the negative sign, minus 3 e to the negative 9t cosine of 3t. That's our first Wronskian. So let's put that on the side here. Now let's solve for our second Wronskian. Remember to take the determinant, so that's cosine of 3t times 0 plus 9 e to the negative 9t minus 0 times, doesn't really matter because 0 plus e to the negative 9t of negative 3 sine 3t. That's equal to 9 cosine, or let me put the e first, e to the negative 9t cosine of 3t minus 3 e to the negative 9t sine of 3t. So let's put that here, 9 e to the 9t cosine 3t minus 3e to the negative 9t sine 3t. And then let's calculate our last Wronskian, because remember, an nth order differential equation generates n number of solutions, so we need 3 Wronskians to have a full solution set. So Wronskian 3 equals determinant of cosine 3t, negative 3 sine of 3t, negative 9 cosine of 3t, sine of 3t, 3 cosine of 3t, negative 9 sine of 3t, 0, 0, 1. So that's equal to cosine 3t times 3 cosine of 3t minus 0 minus sine of 3t times negative 3 sine 3t plus 0 times, doesn't matter what's in it. So we use our trig identities, we'll get that cosine squared 3t, plus 3 sine squared 3t will equal 3. So that simplifies out to a pretty nice number. Okay, for our second solution, we will solve for u2 of t. So that's the integral of second Wronskian, which is 9 e to the negative 9t cosine 3t minus 3 e to the negative 9t sine of 3t times our gt, which is cosine of t still, dt, over our Wronskian, which is 270 e to the negative 9t. You already know the drill, the exponentials cancel out, so we're left with 1 over 270 integral of 9 cosine 3t minus 3 sine 3t multiplied by cosine of t dt. That is our second solution. Well, no, not yet. Remember, we have to multiply by y2 of t. So we would just add sine 3 of t. And that would be our solution, our second solution. So let's just find u3 of t. while we're at it. So take the integral, find of the third Wronskian, which is just simply 3, then multiply by e to the negative 9t, which is our, oh wait, sorry, my bad, no, cosine of t, which is our g of t, over our overall Wronskian, which is 270 e to the negative 9t dt. So that would equal integral 1 over 90 of e to the 9t power times cosine of t dt. And then we would have to multiply by y3 of t. So if we do that, we would just take this e to the negative 9t, add it to the top here. That would be our third solution. So if we add this, that, and that up, we would get big Y of t equals to 1 over 270 cosine of 3t times integral of negative sine 3t minus 3 cosine of 3t cosine of t dt plus that 1 over 270 sine of 3t times integral of 9 cosine 3t minus 3 sine of 3t cosine of t dt. Then we would add our final solution, our third solution, would just be 1 over 90 e to the negative 9t integral of e to the 9t power cosine of t dt. And that last solution we can integrate, just using integration by parts, but I don't want to waste too much of your time, so this is our solution to this differential equation.